Welcome to the session. In this session, I am going to talk about measurement of electrode potential. Electrode potential or single electrode potential is denoted with capital E. It is the measure of tendency of the metallic electrode to lose or gain electrons when it is in contact with its own salt solution. So, when a metallic electrode is dipped in its own salt solution, it may lose electrons or it may gain electrons. The measure of that tendency, losing tendency or gaining tendency measure is known as the electrode potential or single electrode potential E. And regarding the measurement of electrode potential, we cannot measure or it is impossible for us to measure the or to find out the absolute value of the electrode potential. We cannot measure, it is impossible. We can only measure the difference, I mean potential difference between two electrodes which are connected potentiometrically. So if you want to find out the electrode potential of an electrode, that sample electrode must be connected to another electrode that is called as a reference electrode. That must be connected, sample electrode must be connected to a reference electrode, and by finding out the potential difference between the two connected electrodes, we can find out the electrode potential of the sample electrode. Or in other words, we can say we cannot find out the absolute value, we can only find out the relative value of electrode potential, relative value of electrode potential for a given electrode, and that too the other electrode, I mean reference electrode potential must be known to us. It must be either fixed at 0 or its value must be known. So in this way we can find out the electrode potential of a given electrode. Commonly used reference electrodes are standard hydrogen electrode SHE or Calomel electrode. Standard hydrogen electrode, that is a primary electrode, its electrode potential is fixed to 0 and then it is connected to the sample electrode potentiometrically, then the sample electrode potential can be determined. Or we can also use Calomel electrode also as the reference electrode. Its electrode potential must be known to us. Its electrode potential, Calomel electrode potential depends on the concentration of potassium chloride used in that Calomel electrode. Okay, so we can find out the electrode potential of the given electrode by connecting it to a reference electrode whose electrode potential is known to us. Now we will take an example. Example, zinc electrode is taken, and let us discuss how the electrode potential of zinc electrode is determined. You can see in the picture now, this is the zinc plate or zinc rod dipped in zinc sulfate solution. So now we are going to find out the electrode potential of this zinc electrode. This zinc electrode dipped in zinc sulfate solution, this is connected to the reference electrode, standard hydrogen electrode. This is standard hydrogen electrode. Okay, this is the reference electrode here, and standard hydrogen electrode electrode potential is 0. That is fixed to 0. Uh, it is fixed to 0 when the conditions are standard conditions. When we maintain standard conditions, the standard conditions are hydrogen must be passed into the dilute HCl solution that must be of pressure 1 atmosphere, and the dilute acid solution concentration must be 1 molar concentration. So this is standard hydrogen electrode. Now its electrode potential is 0. Now the zinc electrode is connected to the standard hydrogen electrode, and we have a voltmeter also here, voltmeter. This voltmeter shows us the or gives us the potential difference between these two electrodes. Potential difference between these two electrodes. And when we connect the zinc electrode with the standard hydrogen electrode, zinc electrode acts as the anode, and this standard hydrogen electrode acts as the cathode. Okay, so we have to remember one point here. The point is at the sample electrode, I mean the electrode for which we are going to find out the electrode potential, at the sample electrode oxidation is occurring now. So the potential difference shown by the given by the voltmeter, that is oxidation potential. At the sample electrode oxidation is occurring, so the potential difference given by the voltmeter, that is oxidation potential. So when the conditions are standard conditions, so if we maintain here standard conditions, this is standard oxidation potential. Okay, standard oxidation potential of sample electrode. The sample electrode taken here is zinc electrode. So now it will show 0.76 volts. 0.76 volts voltmeter will give 0.76 volts. So it is the potential difference. As the potential of a standard hydrogen electrode is 0, it is the oxidation potential of the sample electrode. As at the sample electrode oxidation is occurring, so the given value 0.76 volts, that is the oxidation potential of zinc electrode. And by changing the sign we can find out the reduction potential of zinc electrode. So 0.76 volts is the oxidation potential of zinc electrode, and its reduction potential must be minus 0.76 volts. So in this way we can find out the electrode potential of a given electrode. Now we will take another example. In this example we have taken zinc electrode. Now we will take another example, that is copper electrode. This is a copper plate dipped in a copper sulfate solution, and this is connected to the reference electrode, that is standard hydrogen electrode, and we have a voltmeter also here connected. Okay, now if we compare the standard hydrogen electrode and copper electrode, standard hydrogen electrode has the high reactivity compared to a copper electrode. So oxidation occurs at the standard hydrogen electrode. At the copper electrode reduction occurs. Now the voltmeter gives the value 0.34. As we are maintaining standard conditions, it gives value 0.34, that is the reduction potential. That is the reduction potential. Why? Because the at the sample electrode reduction is occurring, so the value potential difference given by the voltmeter, that is the reduction potential of the sample electrode. So uh, 0.34 volts, which is given by the voltmeter, that is the reduction potential of copper electrode. And if you want to find out the oxidation potential, we have to change the sign. So the oxidation potential of a copper electrode is minus 0.34 volts. Okay, so this is in this way we can find out the electrode potential of sample electrodes. As we are maintaining here standard conditions, we are getting these values 0.34, and if the conditions are changed, we'll get a relative value. Okay, that value can be taken as the electrode potential of the sample electrode. It may be zinc, copper, or any other electrode. Okay, so this is how we measure the electrode potential of given electrodes. Thank you.